Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidi Sokongwane. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development. Our topic for today is on trigonometry, grade 12s, and then we are looking at 2D and 3D problems, the two-dimensional and the three-dimensional problems. Okay, without any waste of time, let's continue. The objectives of today's lesson: after the completion of this lesson, you will be able to solve problems in 2 and 3 dimensions. Okay, grade 12s, let's see, what are we talking to? Okay, we have angle of elevation and angle of depression. This is the information that we need when we analyze our diagrams. And then now, what are we talking of when we talk angle of elevation? The angle of elevation, grade 12, is measured from the horizontal line. For example, this is our horizontal line here. And then now, this is measured from the horizontal plane going upwards. Look at the direction of your angle there. Then this is the angle of elevation from the horizontal plane going up. That is the angle of elevation. And then when you talk angle of depression, and then we are now talking of an angle that is measured from the horizontal plane, yes, but going down. And then to remember this, grade 12, you can note this by angle of depression, that is D, and then it is measured downwards, that is DD, depression downwards. Okay, so this will be the line that we are referring to as the horizontal plane, and then the angle of elevation will be measured from that line downwards. Can you see that, grade 12? From that line downwards. And then now, if you look at this now, this line, the horizontal plane, the top one, is always parallel to the one that is below there. So we have the parallel lines in between there. And then if you look at this now, grade 12, this is bringing in the transversal line from our Euclidean geometry, where we are having between parallel line, if we have the shape that is forming a Z shape like that one, it is now giving us the alternating angles between the given parallel lines. So what can we conclude, grade 12, is that this angle here is equal to that one. As you can see that it is indicated with the yellow rectangle that they are equal. All right, the same applies. We have another say Z. If we come this way here, going down there, okay, this is also giving us another alternating angles. And then as you can see, the alternating angles between parallel lines, they are equal. Therefore, the red rectangle is indicating that these two angles are also equal. That is the information applicable between your angle of elevation and the angle of depression. Okay, and then we have another information that we need on identifying a horizontal and a vertical plane. And when we talk a horizontal plane, it's a flat plane, grade 12, a flat plane like your floor at the corner of your house. The flat part is the horizontal plane. And then as you can see, this part here, this is indicating a horizontal plane. And then when you talk vertical plane, think about the wall at the corner of your house. The floor will be your horizontal plane, and the walls on that corner will be your vertical planes. And then these are forming 90 degrees to the horizontal plane. As you can see that we are having a 90 degrees. For the good example is to use a corner of the house, the inner part of your house, in reference to the floor and the walls. Then they will give you the horizontal plane and the vertical plane, grade 12. And then now moving forward, we are looking at the trigonometry ratios and the Pythagoras theorem. This is only applicable when we are having what? A right angle triangle or a 90 degrees triangle. It's only then, grade 12, that we can use our trig ratios and the Pythagoras theorem. No 90 degrees triangle, no trig ratios, no Pythagoras. These are only applicable where you have what? A 90 degrees triangle. All right. And then now with the trig ratios, we have this abbreviation here, which is SOH, CAH, TOA, which is assisting us to remember our ratios. So SOH, CAH, TOA, it is abbreviating. The first one, let's see, we have SOH, and then this S stands for sine, and then the O, it stands for Y, and the H stands for R. That means when we talk to sine, we are taking sine is opposite over hypotenuse, and then the opposite is Y, and the hypotenuse is R. And then grade 12, bear in mind that the hypotenuse side must always be opposite the 90 degrees in your right angle triangle. All right. And then now moving on to the next ratio. When we talk the cos ratio, we are talking adjacent over hypotenuse. That is a cos ratio. Cos theta is x over r. So when we talk cos, we talk adjacent over hypotenuse, and then the a is representing the x, which is adjacent, and then hypotenuse always represented by r, as you can see on previous ratio. Lastly, we have a tan theta. And then if you look at tan theta, TOA, and then T stands for tangent theta, and then O, it is Y. Remember, we even indicated the O is Y, and then the A will always represent the X side. As we indicated, A is representing the X side. So this simply means if we are having a tangent of theta, standing at the theta there, you will be talking the opposite over the adjacent side. So this will be opposite, will be Y, and the adjacent will be X there, in reference to your triangle grade 12. And then now moving on to the Pythagoras theorem. Pythagoras states that the hypotenuse side, which is r squared, is equal to the sum of the square of the other two sides. That means the square of the hypotenuse side is equal to the sum of the squares of the other two sides. But this is only applicable where you are having a 90 degrees triangle. Going forward. So now when we are talking the two-dimensional and three-dimensional problem, yes, we will be applying our trig ratios with Pythagoras where we are having a 90 degrees triangle. But there are cases where you have triangles without a 90 degrees. That means it is where now we are going to apply the sine rule, the cosine rule, and then where you need to find the area, we are also going to bring in the area rule. So grade 12, starting with the sine rule now. What does the sine rule state? It states that in any triangle, let's say we are having triangle ABC in this case, in any triangle ABC. So this is the triangle we are talking to, that is triangle ABC. And then the side that is opposite angle A, it will be the side A, as you can see from the yellow color there. And the side that is opposite angle B will be the small letter B side. That means we are talking to side AC, as you can see that it is indicated by small letter B there. And then when you talk to angle C, the side that is opposite angle C will be indicated by a small c there. It's either you can write it as an A, B, or you choose to use a C, grade 12 there. So basically this is the angle we will be referring, or a triangle we will be referring to. And then what does the sine rule state then, grade 12? It states that if you are having a sine of angle A over its side A is equal to the sine of angle B over side B, equal to the sine of angle C over the side C. Or this can be noted, if you look at the first one, we have indicated the angles as numerators, and then this notation can be changed, grade 12, depending on what you want to calculate. So now we can write the side on top and then the angles as the denominators there. Hence we have now a side A over sine angle A, and then side B over side B over sine angle B equal to the side C over the sine of angle C. Those are the possible notations that you can use when you are using a sine rule. And then when do we use the sine rule? You use the sine rule only if you are given two sides and one angle opposite to one of the given side. What do we mean about this? Let's say now we are given angle B is given, side B is given, and the side C is given to you. This statement indicates that if, yes, I am given two sides, side C and B, one of those sides, we must also be given an angle that is corresponding to that one. For an example, if I'm having side B here, angle B must also be given to me so that I can apply the what? The sine rule. It must be two sides and an angle opposite one of the given side. That is when you can apply the sine rule, great chance. And then now with the cosine rule, in any triangle ABC, you can have the A side, A squared, remember it is small letter, therefore it is representing a side. That means the A squared side, this one side here, is equal to the B squared side plus the C squared side minus the 2BC. If you have noted BC there, here it must also be a BC. So it's minus 2BC cos A. So if you look at this angle here, it is having a relationship with the side that you will be calculating. So if I'm looking at side A here, therefore my angle must be angle A there. Okay. And then if I'm looking at side B, look at this, my angle will be angle B there. So if I'm looking for B squared, I must be given the A and the C to be able to calculate that B squared with angle B given to me. So, or you can use it as C squared equal to A squared plus B squared minus 2AB cos C grade 12. What is important is that the side here must correspond with the angle there. That is very important to be able to find that unknown side there. When do we use a cosine rule? To use a cosine rule, you must be given two sides and an included angle. The angle must be included. What do we mean by included? The angle must be between the two sides given to you. Remember, you must have two sides given with an included angle. It must be an angle between. So for an example, let's say we are given A and B here. Values of A and B are given to us, two sides given. So the angle that is included, it must be angle C, which is between the two sides given to you. So we'll be referring to that. So that is when that you can use a cosine rule. What is the difference between this and the previous sine rule? In the sine rule, remember, you must be given two sides and then you must be given an angle that is corresponding to that particular side, okay? Or you must be given two angles and then with the side corresponding to that angle. But in this case, is two sides plus an included angle between those two sides, okay? And then secondly, with the cosine, you can also be given three sides. If all the sides are given to you, then you can be able to find any angle around that, okay? If I am given all three sides, A is given, B given, C given, I'll be able to also substitute B and C. Therefore, grade 12, you will be able to calculate that angle next to the cos there, okay? That is the application of a cosine rule. And then we have the third rule, which is the area rule. So there is a relationship between an area and a cosine rule. Let's see. If I am having triangle ABC again, and then I have to calculate the area of that triangle. Firstly, I can use half BC. That means you must be given side B and side C there, and then angle A. Look at that now. If I am given B and C, and then I also need E, can you see that A is an included angle because it's between those two given sides. That is the relationship between a area rule and a cosine rule. Remember, even in cosine, we need two sides and included angle. Okay, so it's either BC sine A or half of AC sine B or half of AB sine C. Okay, and then to use this rule, we need what? I've already elaborated on that. We need two sides and an included angle, the same as in cosine rule. Okay, and then tips on solving the 2D and 3-dimensional problems, grade 12. The 3-dimensional problems are solved in the same way that 2-dimensional problems are solved. Okay, whether it's a 2-dimension or 3-dimension, the method of solving is the same. And then how do you identify the method? Number one, you identify what information is given to you in terms of sides and angles. That is the key. Okay, number two, you use the appropriate rule in relation to the information that I have just explained to you, that if we are given two sides and one opposite, it's sine rule. Two angles, one opposite, therefore it is a sine rule. With cosine, two sides included angle, area rule, two sides included angle. All three sides, that must be a cosine rule. That is the application, grade 12. Okay, look at example 1 now. In this example, and then before you start answering the question, ensure that all the given information is indicated on the diagram. And then let's go through the statement and check. In triangle ABC, okay, we are given triangle ABC there. It is given that angle A is 40. Yes, angle A is 40. And then we are given BC is 12. Yes, it is noted there, BC 40. AB 15. Yes, it is indicated is 15. And therefore, you are required to determine the sizes of other angles of the triangle. Hence, we are given only one angle A, which is 40. So you need to find angle B and also angle C according to this particular question. And then keep in mind, note that C is an acute angle. And then when we talk acute angle, grade 12, we are talking an angle that is less than 90 degrees. Acute angle is an angle that is less than 90 degrees. That is what they mean about an acute there. Okay, and then now let's start working then. You cannot work before you do what? Identify the given information. What is given to us here? Let's see. We are given two sides. Yes. And then do we have any angle? Yes, we have an angle. And then this angle is opposite one of the given side. Which rule must we apply, grade 12? If we are given two sides, an angle that is opposite one side, that is a sine rule. Okay. Oh, we are applying sine rule here. And then look at this. What is also given us is 15. That side of AB equal to 15. And this is opposite angle C there. That is our starting point then. That means we can calculate angle what? Angle C using the sine rule. Okay, let's start now. What are we looking for? The sine of C, angle C. And then sine C over side AB is equal to the sine of which angle now? That is given to us. That is the sine of A, angle A. And then A is opposite which side? That is side BC. That is the sine rule. And then after identifying the correct ratios, now we can now substitute. Okay, we are looking for C. Therefore, sine C over AB, which is 15, equal to the sine A. What is the value of angle A? Angle A is equal to 40 degrees over the side BC, which is equals to 12. Okay, after substitution, we are now simplifying grade 12. We are having fractions equal sign, therefore we apply what? Cross multiplication. Therefore, we are going to cross this 15 to that sine 40. So we will be left with sine C on the left, which is equal to the 15 sine 40 degrees divided by 12. Okay, but we are not looking for sine C, but we are looking for angle C, all right? So now to be left with angle C on the left-hand side, we are going to take this sine to the right. The minute it moves over to the right-hand side, it is now becoming an arc sine of what? The same ratio that we are having there, over 12. And then from here, grade 12, we take the whole information into our calculator. And then this is now giving us how much? The 53,46 degrees. Rounding off to the nearest whole number, this one will give us what? A 53 degrees. This simply means now our angle C here will be a 53 degrees. And then moving forward now, we are left with angle B. So with angle B, grade 12, we know that if we are working with triangles, bring back your sum of angles of the triangles are equal to 180 degrees. Sum of angles of the triangles equals to 180 degrees. Okay, because we cannot use a sine rule with B. Why? Because we don't know the value of side AC. So you'll be having two unknowns. So to find the value of B, we are relying on the sum of angles of a triangle. Okay, in triangle ABC, so angle A plus angle B plus angle C is equal to 180 because of sum of angles of a triangle. And then how much is A? 40 degrees plus angle B, we are looking for that. And then angle C is equal to 53 degrees, equal to 180 degrees. A 40 plus 53, that is 93 degrees plus angle B equal to 180 degrees. Therefore, angle B will be how much? 180 minus a 93, that is giving us an 87 degrees. Therefore, grade 12, we have calculated the size of all the angles as it was expected from us. Okay, so B is 87. Okay, moving forward. Example 2 now. In triangle PQR, remember we are checking all the given information. Is it indicated on the diagram? In triangle PQR, it is given that Q is 110. Yes, there it is. And then it is given R is equal to 40 degrees. Yes. And then PQ is 13. That is noted in the diagram. Then we need to calculate the length of the other two sides of a triangle. And then look at that diagram. It is not a 90 degrees diagram. Yes, we are calculating sides, but we cannot use Pythagoras. Why? Because we do not have a 90 degrees. We cannot use trig ratios. We do not have a 90 degrees. So we are relying on the rules. And then before you choose the correct rule, you check what is given to you. Or in this case, we are given two angles and a side. Let's see now. This side is opposite this angle. Okay, that means we are given two angles and an opposite side. Two angles opposite, therefore it's a sine rule. Okay, happy now we know the correct rule that we need to apply. It's a sine rule. And then what we need to calculate is the other two sides. Which one is easier to calculate, grade 12? Is the PR, because we already have an angle that is opposite to that side. Okay, can we do so now and calculate PR? Yes. So we are having the side that we want to, what we want to calculate, which is PR over the sine of an angle. Which angle are we looking at? 110 degrees equal to, and then on top, you started with the side. You must also start with the side when you're writing another ratio. So you refer to what is given, both an angle and a side. Which side is given? That is PQ, which is how much? 13. Over the side, this side is opposite which angle? That is sine 40 degrees. And then from here now, we can now cross multiply this sine 110 to 13 because we are looking for PR. That will be 13 sine 110 degrees over the sine of 40 degrees. Straight into our calculators, grade 12, and then this will give us a 19 units. It's 19,00, so rounding off to the nearest whole number, it will be what? 19 units. So now we have the value of PR being 19. After calculating information, put it on the diagram. Okay, now we are left with one side to calculate, that is QR. Okay, and then if you look at QR, let's see, QR is opposite angle P. Do we have angle P? No. Can we calculate angle P? Yes, because we are in a triangle and then we already have two angles, then we can calculate the unknown angle. Then to find the value of P, angle P, we are taking the sum of angles of a triangle, which is 180 degrees. Then we subtract the available angles, which is 110 out. Subtract 40 out. Where does it come from? Sum of angles of a triangle. And then now this is giving us how much? 30 degrees. Happy now, grade 12? We have an angle. If we are having an angle, therefore, we will be able to find the side QR. Let's do so. We are looking at the side QR. We start with what we want to calculate. On top, side QR. And then over, the angles is 30, therefore it will be sine 30, opposite angle, equal to, you can take any other side, either the PR or the PQ, but the safest way is to take what? The PQ, because it was given to you. Should you go wrong with PR, maybe your answer is wrong there, so that it cannot affect your answer for QR. So be wise, grade 12. Always go for what is given to you than the one you have calculated, to avoid going wrong, okay? And then now let's go back. We have a QR side, which is over the sine 30, and then we are going to rely on PQ now, because it was given to us as being 13, and then the opposite angle is 40, then it will be sine 40 degrees. Cross multiplication, I know that you are now familiar now with this, and then that will be 13 sine 30 degrees over the sine of 40 degrees. Into your calculator, grade 12, straight to the answer. This is giving us a 10,11. That is the length of the side QR, 10,11 units. Okay, that is the sine rule application. Moving on to the rule number 2, we are talking to a cosine rule now. And then calculate the length of BC. That is our question. Before we can calculate anything, you analyze the diagram. What is given to you? Which rule must I apply? Okay, let's check. We are given two sides, yes, AB and AC, and an included angle, an angle between those two sides. Therefore, cosine rule can work and area rule can work in this condition, right? And then now let's see, we have to calculate the length of BC. Let's do so, grade 12. Okay, we are looking at BC. Then it will be the side that you want to calculate. We start with that. BC squared is equal to the other side, AB squared, plus another side, AC squared, minus 2 into AB. You take it as it is from there, and then AC from there as it is. And then we have the cos of, remember, a cos must correspond with the side. Remember, an angle of your cos here must correspond. It must be an angle that is opposite that side. So which angle is that? That is angle A. Do not take any angle, grade 12. It must be an angle that is opposite the side that you will be calculating. All right. Correctly notated now. And then we can now substitute, okay? As we continue, remember this side, we will be left with only BC If the side loses an exponent, this will gain a square root of whatever is on the right-hand side. We were supposed to have a plus minus if we lose a square root on the left, but because we are looking at the length, a distance can never be negative. Negative is only showing the opposite direction, so it will always be a positive grade 12. And then now let's substitute. We are looking at the value of AB here. So how much is AB? 10. And this is squared. Do not forget that square. And then AC is how much? 12. And then this is squared minus 2. We put in AB again. It must be the same as that one. That is 10. And the AC must be the same as this, which is 12. And then we have the cos of A. How much is our A angle? 125 degrees. And then grade 12, you can just put this into your calculator straight to the answer, and therefore this will be giving us how much? The 19,54 units for that particular side BC. So the mark allocation here will be 1 for selecting the correct rule, substitution, and the answer. So this question worth 3 marks, grade 12. Okay. Cosine rule example 2. Calculate the size of angle D. Always check what is given to me. Okay, in this case, we are given all the sides. All 3 sides are given. Oh, that means it's cosine rule. Remember, cosine rule works with what? 2 sides included angle and 3 sides given to us. If we are given all 3 sides, that means they are expecting you to calculate what? Angles. Okay, so in this case, we need to calculate the size of angle D. We are looking at that angle here. Okay, because we have all 3 sides, it's a cosine rule. And then this angle D is opposite which side? FE or EF. Okay, so that means now the angle must correspond with the side, remember, on the left. So we are going to put our side here, EF squared, and then the other 2 sides, DF squared plus the DE squared minus 2 what? Same DF, DE, and then the cos of the angle that is opposite this side, which is cos D. Okay, can you see grade 12? This must correlate the angle and the side. The minute that is wrong, everything goes wrong. And then now let's substitute here. We're looking at EF is given as 9,3 squared. DF is given as 6,9 squared. DE is given as 3,5. Do not forget your squares. Minus 2. DF is exactly the same as that one. It will take 6,9. And then DE will take 3,5. It's the same thing. And then we are looking at cos D. Okay, that is your substitution. But remember, grade 12, our focus is here. We want to solve for D. So you use mathematical application to solve, simplify, and manipulate the question until D is the subject of the formula. Okay, now we are having 9,3, which is squared. Put it in your calculator. It will give you an 86,49. 6,9 squared will give you a 47,61 plus a 3,5, which will give you a 12,25. Minus 2 times 6,9 times 3,5 is giving us 48,3 with the cos of D. Okay, look at that, grade 12. Then I am going to take this part here with the minus 48 and transpose to the left. Therefore, it will change its sign to positive 48,3 cos D. So on the right hand side, I am left with the 47,61 plus 12,25. I am also taking this 86,49 to the right now. Then it will become minus 86,49. Let's continue, grade 12s. And then now we are having a 48,3 cos D. So we are adding everything on the right hand side. So we end up with an answer minus 26,63. And then from here now we divide both sides by 48,3. So we end up with cos D this side. The 48,3 will cancel 48,3. So on the right hand side, we have that minus 26,63 over 48,3. So if you put this and try to find a simple fraction, your calculator will give you 2663 over 4830. Okay, and then we are not looking for the cos D, but we are looking for a D grade 12. And then now if you look at angle D, we are going to take this cos to the right hand side. It is now changing to a cos of that particular value, 2663 and then 4830. And then someone may ask, why are you leaving a negative sign? Remember, this is taking us to the trig equations. If you are having a minus, it is indicating that you are looking at the cos where the cos is negative. In which quadrant is cos negative? That is quadrant 2 and quadrant 3. Okay, quadrant 2 and quadrant 3. But now if you look at D here, you can see that D is an obtuse angle. Therefore, we will be calculating according to our angle there. Okay, it is more than 90 degrees. All right, let's see now. We cannot say what we are having here is a final solution because we are going to look at the cos where it is negative. So this will be our reference angle of D. So you press your second function cos, and then with the fraction button, you put in that information. Omit a negative grade 12, do not put a negative, and therefore it will give us the reference angle of 56,54. Can you see that? This cannot be the value of D. D is far more than 90. Okay. And then if that is the case, remember, if you try to find, you'll be having something that if that is your 90, can you see that this is more a little bit from 90? Something must be added there a little bit, but it is before 180 degrees. Can you see that according to the diagram, grade 12? You must be able to identify that. And therefore from here, we are looking at the actual value of D, which is obtuse now. Therefore the D, we look at the quadrant where is negative, second quadrant. We are having a reduction 180 minus, and then we are subtracting our reference angle, which is 56,54 from our calculation there. And therefore this is giving us 123,46. That will be our actual value of angle D. I hope we are still together, grade 12. So this is how you find the angle using the cosine rule. Give these problems more attention because they are a little bit complicated. Go to the cosine activities where you are calculating an angle. Practice more on that one, grade 12. Okay, area rule. Remember, with the area rule, you must be given two sides, included angle. Let's see. Okay, in triangle ABC, yes, we have triangle ABC. A is 25, noted. AC is 12, yes, and then the AB is 10. What is given to us now? Two sides, yes, and included angle, yes, the angle between the two sides. Therefore, you can apply the area rule. Okay, now let's start calculating the area of triangle ABC is equal to half of the two given side, right? Which side is that? That is side AB and side AC with the sign of included angle, which is angle A. And then we can now substitute the values. That is half of 10, AC 12, and then with the sign of 125 degrees. And then into your calculators, grade 12s, straight to the answer. And then this will give us an area of 49,15. This will be unit squared because it's a square unit, because it's an area now. It's not a distance, okay? It's a square unit. Remember that one, grade 12, in terms of units. And okay, in this case, it's given as centimeters. We can put in the actual one and say the square centimeters because it is given there in centimeters. Okay, basically that is how you apply those 3 rules, grade 12s. Okay. Okay, let's analyze this diagram here together. In the diagram AD, that is the AD is from here to there, AD represent a flag of pole. It's like there's a pole there and then a flag is attached at point D there. And then this pole is here 5 meters long, the length of 5 meters, which is perpendicular. Perpendicular means 90 degrees, okay? And then this pole is perpendicular to the horizontal plane. Remember, I've indicated earlier on that the flat part is the horizontal plane. So this pole AD that we are talking to is perpendicular to the horizontal plane. Think about the corner of your house, inside the house, and then this simply tells us this is 90 there. Okay. An observer at C, there's an observer standing there, knows that the angle of elevation of D is 35 degrees. Can you see that, grade 12? Remember, this line is flat. And then now from there going up, that is why we say it's an angle of elevation. From the horizontal line going up, therefore it's an angle of elevation. And then while another observer is at B, in the same horizontal plane, this is a horizontal plane, as C finds that angle of elevation of D is 42. From the horizontal plane up, it's elevation. Okay, remember depression is up, down. Okay, going down is depression. Okay, and then that means that given information is indicated on the diagram. And then we are also given that BAC, angle BAC, that is BAC is equal to 65. Yes, it is noted there as a 65 degrees. So basically, grade 12, what is new here is that angle of 90 degrees where we have a perpendicular to the horizontal plane. So we can just take that to our next diagram there. Okay, without any waste of time, grade 12, I want you to go through activity 1, and then your 3 minutes starts now. You are answering 1.1 and 1.2. 3 minutes starting now. Okay, grade 12, let's see how far did you go with the problem. Our first activity was write down the sizes of the angles. That is angle DAC and angle DAB. The aim is to write. If the question says write, no calculations, okay? That means your answer is already on the given statement. I think we have already answered that together previously, so because it was given that the pole AD is perpendicular to the horizontal plane, which have already given us the values for that. Then we can just conclude and answer that, okay, therefore, angle DAC is equal to angle DAB. They are both equal to 90 degrees. Why? Because it is given that the pole AD is perpendicular to the horizontal plane. That is where that 90 comes from. Okay, and then moving to 1.2 now. How far is each observer from the foot of the flag? When you talk foot of flag, grade 12, we are talking this point A here. Okay, how far is each observer? Remember, our observers is observer C and the observer B there. And then if they say how far is each observer from the foot of the pole AD, and then you round off your answer to 2 decimal. It's very important to read your statement and understand what is required of you, okay? Number 1, they say from the foot of the pole, and then here is your observer. Can you see that? We are looking at the length of AC here, because it's from C to A. And then also from A to B, because we are looking at both observers. After analyzing that is then that you can answer the question. Can we calculate that? We have now a 90 degrees. The minute we have 90, our life is easy. We don't look at the rules, but we look at what? Pythagoras and the trig ratios. They work well with this type of a question where you are having a 90 degrees triangle. Okay. Remember, this 90 degrees is only in 2 triangles. That means which is the vertical planes. The triangle ACD and the triangle ABD, sorry. And then now let's look now. We want to calculate AC, all right? Can you see AC lies in triangle ADC? So in triangle ACD, we are saying we are looking for side AC, standing at angle C here at 35 degrees, okay? Let's see now what is also given to us is that 5, okay? Let's dismantle this triangle that we are referring to and take it out here. We are talking 5 meters of AD, and then we have C that is 35 degrees. Remember, there's a 90 degrees triangle there. And then now from here, now we are looking at side AC. We are looking at this side. What is given to us? It's an angle. And then this angle to that 5 given to us, 5 is opposite. So the side that we are looking for is an adjacent. So we are referring to which angle? To this 35 degrees angle here. 5 is opposite to that, and then the AC that we are looking for is adjacent. So you go to your trig ratios, grade 12, you look at the one that is having opposite and adjacent. Remember, that is the TOA. That means it's a tangent. You need to use tangent then. Therefore, we are looking at the tangent of which angle? 35 degrees equal to the opposite side, which is 5, over the adjacent side, which is AC that we are looking for. Can you see how easy is that? And then from here, you just cross multiply. This AC will go there, and then it's 5 over, we take tangent to the place of AC, it will be tan. They just change positions. Tan 35. Into your calculator, straight to the answer. So AC is 7,14 meters because it is given in meters. Can you see that, grade 12? Okay, we are having 7,14 meters for AC. And then let's calculate another length from the observer to point A again. We are looking at AB now. And then if we take out the triangle from that one, this is the type of triangle we are talking to. We have 90, we have the AD pole there, and then we have observer at B. And then we are having an angle of 42 degrees here, and then we have 5 given to us AD there. If you are sitting at 42 there, you can see that AD is opposite to that angle, and then we are looking at what? AB. AB will be the adjacent to that particular angle. So can you still need a tangent grade 12 to solve that one? Let's do so now. We are working in triangle ABD. In that triangle, we are taking a tangent of 42 degrees, which is equal to the opposite side, which is 5, over the adjacent side. We are looking at AB. And then we cross multiply. AB will go this side, and then we are having 5 over tan will take the place of AB. Then this will be tan 42 degrees. And then into your calculator, straight to the answer that is giving us 5,55 meters. Therefore, AB is 5,55 meters, grade 12. Okay. So we have rounded off our answers to 2 decimal. Be careful on rounding off, okay? And then the mark allocation for this, for number 1, it will be 2 marks there for finding the 90 degrees for both angles. And then for 1.2, it will be a mark for substituting into the correct ratio. Number 2 for simplifying, and the value of AC. The same applies, substitution, simplification, and the answer. The whole 1.2 will worth 6 marks, grade 12. Moving on, the next activity, we are taking 7.1114 and 55 meters to the diagram. Okay, we are having 7,14 meter, and then we have 5,55 meters there. Okay, grade 12, let's take 5 minutes to answer this one. 1.3 and 1.4. Your 5 minutes starts now. Okay, grade 12. Let's see how far did it go with this one. And then let's 1.3. We were expected to calculate the distance between the two observers. And then your observer, remember, is C and B. At least it is also indicated to you that it's C and B then. And then round off your answer to 2 decimal places. Now, we are looking at the length CB. And then can you see the CB lies in triangle ABC? If we dismantle that out, we are having triangle ACB there. And then we have already calculated AC from the previous solution, and then AB as 5,55. And then we are expected to calculate CB. And then this angle here is given to us, which is 65 degrees, angle CAB. Okay, that is the given information. Then we are looking for CB there. Can you see that, grade 12? We have 2 sides and included angle. Therefore, the application is a cosine rule. That is how you identify that. We can now go cosine. The unknown side is CB squared equal to the other 2 sides, AC squared plus the AB squared minus 2 times this AC side, the AB side, which is the cos of the angle that is corresponding to that side. Can you see that? We are talking to angle of 65 degrees. And then let's start substituting. Remember, this side will lose an exponent, and this one will gain a square root sign. Positive only, ne? And then AC is how much? 7,14 squared plus the AB is how much? 5,55. This is also squared, minus 2. AC come in, 7,14. Remember, it must be exactly like that one. And then the AB is 5,55, exactly like the second bracket here. And then we are having the cos of 65 degrees. The square root is for the whole thing. And then you take everything into your calculator, and then this will be giving us how much? The 6,95. And then they say round it to the nearest, oh, this one is 2 decimal, sorry. So the rounding off is correct, 6,95 meters for that particular 1.3 question. Okay. And then now the mark allocation is for selecting the cosine rule for substituting and the final answer. Therefore, 1.3 will worth 3 marks, grade 12. And then let's look at 1.4. And then in 1.4, you were expected to calculate the area of triangle ABC to the nearest whole number now. Remember, the area and cosine, they need the same information, which is 2 sides and included angle. Therefore, happy now we do have all what we need, so we can find the area of that particular triangle. Therefore, it will be the area of triangle ABC, which is equal to half of first given side, that is 7,14. The second given side, 5,55, and then the sine of an included angle, which is 65 degrees. Into your calculator to the answer, this is giving you 17,98 square meters because we are talking to an area. But because the question says round it to the nearest whole number, you continue, grade 12, and write this as 18 square meters. To the nearest whole number, it must not contain any commas or decimals on the answer there. So our final answer here will be the 18 square meters. Moving forward, I hope we are still together, grade 12s. And then let's analyze this question now. We are given the figure that shows a picture of a roof truss. A roof truss is this wood that we see when they build houses. Before they roof, they put those designed wood there, and then we call them the roof truss. And then what type of a triangle is ACE? Give reasons for that. And then 2.2, provide reasons. Why is AF equal to FE. I'm giving only 2 minutes, grade 12, to analyze the two diagrams and try to find the reasons why are these two statements true that are given to us. Only 2 minutes to analyze that one. Thank you. Okay, grade 12, let's see. Right. Remember, when you look at the roof truss, you must be able to contextualize your real situation diagram. Remember, you are technical mathematicians, so most of your questions will be related to the real situation. Like when you look at this truss, the roof truss, this is relating to the civil technology learners, all right? And then now, what we know that is that this pole here, it is always designed in such a way that it forms a 90 degrees there. That is a practical thing. You must be able to observe that, grade 12, on your own without doing any calculations. All right, it is always designed at a 90 degrees angle. Okay, now 2.1. What type of a triangle is triangle ACE? So we are looking at triangle ACE here, and then look at what is given to us. Is CB is 4, and then is equal to the CD is also 4. AP is 2,5, and then the DE is also 2,5. That means the whole length of AC here, it is equal to 4 plus 2,5, which is 6,5. The same applies with CE here. 4 plus 2,5 will give us a 6,5. This simply means, grade 12, now the two sides are equal. And then what type of a triangle is that one? It's an isosceles triangle. A triangle whereby you are having two sides equal. And then if that is the condition, remember also the base angles must also be equal there. Is that the case with this one? Yes, we are having a 50 degree there and also a 50 degree there. Therefore, what type of a triangle is this one? This is an isosceles triangle. Why is it an isosceles? Two sides are equal and the angles opposite equal sides are also equal. Okay, the two sides are equal and angles opposite those equal sides are also equal. They are both equal to the 50 degrees. Okay, and then provide a reason now. Why is AF, line AF starting from here to here, is equal to the line FE? Remember, we have just indicated that if this is a roof truss, that means this is 90 degrees to that one. Okay, so in these two triangles now, we are having side AC, which is equal to side CE. We have just indicated that they are both equal to 6,5. That is given to us. And then we are having a side CF, which is common to both triangles. And then now we are having angle AFC, which is equal to the angle EFC. They are both equal to the 90 degrees. That is also given in terms of the diagram. So if you are having 1, 2, 3 conditions, these conditions are giving you a condition of congruence. Therefore, triangle ACF is congruent to triangle ECF. Okay, and then if that is the case, therefore AF is equal to EF out of congruency. And the reason for congruency is the right angle, hypotenuse, and a side. We have a right angle, we have the hypotenuse side, and the side that is shared by the two triangles. That is the reason why those two lines are equal. And then activity number 2 now, grade 12. Look at 2.3 now. I am giving you 3 minutes to answer that. You are determining the length of CF and the length of EF. 5 minutes starting now. Okay, grade 12. Let's see how far did it go. We are determining the length of CF. Let's check we are moving from C to F there. And then also the EF, that means from E to F there. So CF is that common side for both triangles. Remember, we have indicated that the roof truss is forming a 90 degrees triangle there, and therefore we are in triangle, either triangle ACF or you can use ECF. It both works well. Okay, let's say Elena decided to take triangle in triangle ACF, and then we are looking at the side CF there. We are looking for that particular side. Can you see that side is opposite 50 degrees angle? Yes. And then now the given side to the 50 degrees is the hypotenuse side because it's opposite 90 degrees there. Therefore, this is our hypotenuse. And then the one that we are looking for is the opposite side to the angle that is given to us. So which ratio, grade 12, are we going to use if we have opposite and hypotenuse? That means from your SOHCAHTOA abbreviation, can you see that you are looking for the sign because it's the one that is having opposite and hypotenuse? Let's do so, grade 12. We are looking at the sign. Which angle are we referring to? The angle of 50 degrees is equal to the opposite side. What is the opposite side to that angle? That is side CF over the hypotenuse side, which is the one that we've indicated is 6,5 when you add both lengths there. And then now, can you see that you can now find your CF by cross multiplying 6,5 to sine 50. So on the right, you'll be left with CF 6,5. Start with 6,5 grade 12 and then your sine of 50 in order not for 6,5 to distract with your angle of 50 there. And therefore your CF into your calculator, this will give you how much? The 4,98 unit, because we are not given any units, they will just indicate units there. So that is the CF. So CF is 4,98. We have just calculated that. And then secondly, we need to find the length of EF. EF is in triangle CFE. And then now let's look at the side that we are going to calculate. Okay, we want EF, which is this side here. And then in reference to our angle, this side is an adjacent side. And the one that is known to us is opposite to that angle or its hypotenuse side to that angle. You can use any of those trig ratios, grade 12. Let's say this particular learner now saw adjacent and opposite. That means the learner will be applying the tangent now. Opposite and adjacent. That means it's a tan of 50 degrees. And then the opposite side will be that one that we have just calculated, 4,98 over the adjacent side, which is the EF that we want to calculate there. And then we cross multiply these two in order to take EF up there. Then it will be EF is equal to 4,98 units over the tan of 50 degrees. And then into your calculator, straight to the answer, we have the EF being 4,18 units. Alternatively, grade 12, another learner may see adjacent and hypotenuse because knows that this side is 6,5. Okay, then decided to use adjacent and hypotenuse, therefore that learner will be using the cos now. So that will be the cos of 50 degrees. A cos is adjacent. What is adjacent? EF over the hypotenuse side, which is 6,5. And then now you cross multiply this to cos there. That will be 6,5 and the cos of 50 degrees equal to the EF. This must automatically give us the same answer, grade 12, of 4,18 0.18 units. Basically, those are the two ways that you can apply to find the required site. And then remember now, if the examiner can say what is the value of AF, this will still be 4.18, because we have proven earlier on that the two triangles are congruent, therefore AF is equal to the EF. And then the mark allocation around this one, for CF length, it will be substitution into the correct answer, cross multiplication, and the answer there. 3 marks for that. Substitution, simplifying, and the answer, 3 marks for the EF. So the whole question will worth 6 marks, grade 12s. Okay, now let's go to the activity number 3. And then I think that will be the last one for the day. The picture shows a crank mechanism of a petrol engine. Remember, you are technicians, grade 12, your problems will always be related to the real life situations. So it shows a crank mechanism of a petrol engine. In the diagram alongside, an arm OA is equal to 10 centimeters indicated, yes, and it rotates clockwise about O. That means now this is point O, it comes from this point here. And then if it is rotating clockwise, they mean this point here, it moves along this line of a circle, moving clockwise to this direction. As it is doing so, it is pushing this line here to move up and down there. Okay, that is the mechanism of that crank mechanism of an engine, petrol engine we have. And then now, if we take this relating to our mathematics now, we have an OA which is 10 meter long, and then if this point rotates clockwise about O, and the connecting rod which is AB there, that is moving up and down, is 30 centimeters, and then this is also 10 centimeter there, and then an end B is constrained to move horizontally. Grade 12, as I've indicated to you, as you shift that point here moving in that direction, this point will also be shifted to and fro there horizontally. And then an angle AOB is equal to 50 degrees there. Therefore, this angle is 50 degrees. This simply means an angle between that arm and that horizontal line where the movement is happening. Okay, take note that AB is not a tangent. Sometimes we assume that the minute you see a line touching a circle, you assume it's a tangent. You can see that, grade 12, if we had to continue with this line, it will come inside the circle like that. Therefore, it is not a tangent. At least it is indicated to us that is not. Therefore, you cannot apply the tangent theorems here. Okay, then we have analyzed everything now, grade 12s. That A angle is not 90 degrees because it is not a tangent. It will be 90 if that line AB is a tangent, because a tan is perpendicular to radius. But that is not the case in this particular problem. Okay. Okay, now let's look at the 3.1. Determine the size of angle ABO. Angle ABO. Look at that. We are looking at this angle here. Okay, ABO. And then look at what is given. We do not have 90 degrees because this is not a tan perpendicular to radius. AB is not a tangent. If that is the case, we deviate from 90 degrees. Look for something that you can apply. Let's check what is given to us. We are given two sides. Okay, we are given two sides. And then what is in relation into this given two sides? One side is given with an angle plus an angle, opposite angle. Which rule is that one, grade 12? Remember, if we are given two sides and one side with the corresponding or opposite angle, that is a sine rule. Okay? And then look at B. B is opposite the side of 10 that is given to us. That means in this case, we can apply the sine rule. And then what are we looking for? Angle ABO. So we can look at the sine of angle ABO over side. Which side is that one? That is side AO. Equal to, we are going to take the one which is having an angle and a side value now. And then starting with the angle, that will be the sine of O, angle O, over the side AB. And then let's do our substitution now. We are looking at the sine of ABO, angle ABO. And then AO is how much? 10 given to us. Sine of O, sine of 50 degrees. And then AB is equal to 30 units there. And then now we are looking at sine ABO equal to cross multiplication, grade 12 to that side. It will be 10 sine 50 degrees over 30. Okay, I am avoiding simplifying partially. I'm waiting for the final answer. It's only then that I can touch my calculator. All right, because rounding off in between in trigonometry will always affect your final answer. So we are avoiding that by all means, grade 12s. So this side, we will be left with angle ABO because we are looking for that. We need to get rid of that sign. So when we take this sign to the right, it will be now an arc sign of whatever you are having there, the 10 sine 50 degrees over the 30, not 30 degrees, 30 units, okay? Over 30 units there. And then into your calculator, straight to the answer, angle ABO will be 14,79 degrees because they say round off to 2 decimal places. Okay. Hence, determine the length of OB if ABO is 14,9. Grade 12, can you see now the answer was already given to you on the next question that the value of ABO must be 4,79. So be aware of such questions. They can also assist you to be correct when you go wrong on the previous one. Okay. And then now if we are determining, let's put in the given information first. What we have calculated, angle ABO is 14,79 degrees. And then we need to calculate the length of OB now. Okay, let's look at OB. OB is this side here. Okay, can we calculate that? No, we cannot calculate if we do not have that particular angle there. All right, if we can get that angle A, it's only then that we can be able to find OB because now we have two unknowns. All right, let's start calculating angle A. Angle A with sum of angles of a triangle, which is equal to 180. We subtract the given angle 50 degrees and the calculated one, 14,79. This is out of what? Sum of angles of a triangle. And then 180 minus 50 is 130, minus 14,79 is 115,21 degrees. That means that is the angle A. And since we have angle A now as being 115,21, we can now find OB. Side OB over the sine of angle 115,21 because it's the one that is opposite that. Remember previously we said avoid using what you have calculated if you are having the original given to you. So we will have a side which is 30, opposite angle sine 50 degrees. So OB will be equal to cross multiply this to 30. That will be 30. The sine of 115,21 over the sine of 50 degrees, grade 12. So put this into your calculator straight to the answer. We end up with the answer 35,43 units because we are talking the distance. And then application of marks will be allocating 1 for substitution, one for simplification or cross multiplying for the arc sign, and then 4 marks for 3.1. And then for 4.2, for finding the value of A, for substitution, for cross multiplying, and for the answer, that will worth 4 marks, grade 12. And then now 3.3, which is the last activity there. calculate the area of this particular diagram now. Remember, we have calculated the angles on the previous calculations where we are having an angle A being 115,21, and then we have angle ABO being 14,79. And then now in this case, we need an area. We know that if we calculate area, it must be two sides and included angle. Do we have two sides? Yes. Do we have included angle? Yes, calculated from the previous. Then we can go straight. Area of triangle AOB is equal to half the two sides, 10 and 30, included angle, sine of 115,21 degrees. And then into our calculator, straight to the answer. This is giving us how much? 135,7. That is to 1 decimal places. So we'll just stop there at 1 decimal. Please ensure that your rounding off is correct, grade 12. And then the mark allocation, it will be substitution and the answer. They can also give you substitution into the correct formula there. So it can worth 2 to 3 marks to answer that particular question correctly, grade 12. You are more than welcomed also to use the sides. Remember, we have calculated that OB is 35,43. You can use that one, 30 and 35, included angle will be B. Or 35 with the 10, included angle will be 50. You will end up with the same answer as that one, grade 12. Thank you very much. This brings us to the end of the session of today. This was brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center, and it was broadcasted by Pagama Research and Development. Thank you very much. Till we meet again next time. Bye.